Welcome back to the 11th chapter demo exercise. So in this chapter, we will import a ball bearing model and try setting up the 3D contacts. In the end, we will try reviewing the contact forces between the ball bearings in this particular MotionView model. Okay, so let's get started. So here we'll be importing the ball bearing model that's been already built. So let's go to the CAD import utility. Okay, so in this particular section, I want to import the CAD along with the mass and inertias. So I leave it as it is for the first option for the import. And then the file that I want to import is a parasolid file. So I keep it as it is. So I go to this particular icon and go to the 11th chapter. I have ball bearing.txt. So this is a parasolid file. And next I'll be going and putting a check mark on this, since I mentioned in the theory class that for 3D contacts, it's always preferable to put a check mark on this and set the slider to an average value of 5. Okay, so once this is done, we can leave all other options as it is and just hit on OK. So MotionView invokes hypermesh in the background that basically imports the CAD, applies a mesh on the solid surfaces, and it calculates the volume, center of mass, and the mass of inertia. So once the hypermesh process is complete, the import CAD dialog box opens once again, and it contains a table of components along with the density information, okay, the mass, density, and the volume information. So in this particular table, you can go ahead and if you want to change the mass of any of these components, you can change the density of any of these components by clicking on the particular component, going here and change the value and clicking on apply. Okay, so the density cannot be changed once the import is complete. So if you want to change any value, it's at this time that you're supposed to do it. Okay, so you can leave everything as it is and say OK. So it says importing the file succeeded. So there were no other error messages, and it successfully imported the model. Okay, so now let's go ahead and review the model by navigating through the model browser. So just expand bodies. So as usual, we have the default ground body, and this is the rim that you can see, which is the outer component here. It gets highlighted. I hope it's clearly visible. That's the rim. The inner race refers to this red disc or red cylinder that you can see is basically the inner disc or the inner race. The outer disc is the blue structure. Okay, and the rim will be the yellow part that you can see. Okay, so once that is done, this is ball 1, 2, 3, 4, 5, and 6. So there are 6 balls in this ball bearing, and we'll try to set up the contact between each of these balls with the inner race, outer race, and the rim. Okay, so to hold them in space. So now let's save this model as ball bearing contact.mdl. So file save as model. So ball bearing contact.mdl. Okay, so I just did that. Now let's review the mesh and create the joints. So go to the graphic option here, okay, and click on the model that selects this entire model, and then click on the mesh lines. So you'll know how finely this particular CAD is meshed automatically. Okay, so this is how it's meshed with uniform, almost uniform mesh size. Okay, so this is a very good quality mesh that's used on this model. So you need to create now the joints for this particular model. Okay, so let's go to the joints, create joints icon on the toolbar. Okay, let's give meaningful names as an able name for creating the joints. So we'll call this fix outer race. let me use underscores. So fix outer race, and in the variable name I'll give fix outer race. Okay, and this is supposed to be a fixed joint. So I'll go to the drop down menu and click on fixed joint. Okay, and the type is single, so say okay. So the body 1 is gonna be the outer race, and the body 2 will be the ground body. Okay, and the origin will be the race center of gravity. Okay, so outer race center of gravity, and say okay. So you got a fixed joint here, so it fixes the outer race. And next let's go to the rim. So to create another joint, so call this the rim joint. The variable name will be rim, and here we're going to create a Revolute joint. Okay, so say okay, and the body 1 will be the rim, and body 2 will be the ground body, and say okay. So the origin will be the CG of the rim, so which is at the same location. And now we need to create the orientation for this Revolute joint. So that should be about the global x-axis. Okay, so this is right now about the global z-axis, so you need to change the orientation so that it aligns itself to the global x-axis. So you need to go to this drop down menu, click on vector, double click on this vector option, click on global x. Okay, so now you can see that it's oriented in the right direction. Okay, so once you set up these two joints, now is the time to go ahead and create other contacts. So you will be individually creating contacts between the inner race and the balls, the outer race and the balls, and also the rim and the balls. So this means you're gonna have 6 times 3, so you'll have 18 contacts in this contact model. So you can right click on the contact. So the two ways of creating contact, you can either go to the model browser, right click, add, force entity, and go to contact, or you can go and directly add contacts from this toolbar. Okay, so I'll go here, I'll give a label name saying it's a contact between ball 1 to inner race. Okay, so the variable name will be ball 1 inner, so ball 1 inner. Okay, and it's going to be a rigid to rigid contact, and click on OK. So please note that an output is automatically created for each contact entity that will be creating. Okay, so do keep a watch on this as and when I create new contacts. So here for this, in the connectivity tab, for the body 1, double click on this and click on ball 1 and say OK. And for body J, this is contact between the ball and the inner race, so select inner race and say OK. So you can click on the highlight contact side. Okay, so you can get to know that this is shown in red color. Okay, so the contact side of both the bodies in contact are as shown here. Okay, so this gets highlighted. You can see the difference when I uncheck this and check this. Okay, so MotionView automatically tries to orient all the mesh elements surface normal along the force of direction during the import CAD utility itself. Okay, so in the case the contact is not assigned as per what the user desires, you can go and click on the material side to swap the direction of the contact normal. Okay, so right now it looks good, so I'm leaving it as it is. Okay, and one more thing that you'll have to notice is this particular option which has mesh errors is grayed out. This means that the meshing has been done properly and there are no mesh errors involved. So if you try to use an external CAD model and interactively mesh the model in HyperMesh, and when you try to import, and if it is either not enclosed or if it has T connections, then this particular option will be highlighted. So you can get to know that there are some meshing errors in your mesh model. Okay, now let's go to the properties here. So in properties, go to the normal force tab. So we'll try to use the impact contact model. So we'll use the default value, which is 1000 for the stiffness, 2.1 for the exponent, the damping is 0.1, and the penetration depth is also 0.1. Okay, now you can click on the friction and you can verify that the friction is disabled. So neither the static nor the dynamic friction is applied here right now, so it's disabled. And go to the advanced tab. Okay, so even these options are not needed to be checked for this particular exercise. Okay, so this advanced tab basically it offers more options to control the contact simulation, and also it basically controls the simulation when the contact is first detected, and it is only useful in case of those models which have intermittent contacts to provide more accurate results. So only in those cases when we have intermittent contacts, only then we try to use these two options. Otherwise, for this particular model, we don't have to check these two options. We can leave them as it is. Okay, now we'll repeat the same thing that we did for the other contacts as well. So let's move forward and create the other contacts. So right click on this, call this ball to inner. Ball to inner is a rigid to rigid contact, and the body I will be the ball 2 and the body J will be the inner race. Similarly, ball 3 inner race, ball 3 inner. Okay, so body I will be ball 3 and body J will be the inner race. Next one will be the ball 4 and the inner race. So it is ball 4 inner. Click on OK. So this will be ball 4 and body J will be the inner race. Say OK. Go to the next contact, ball 5 inner. So here ball 5 inner race. So you can add inner race here and say OK. So there should be ball 5 and body J will be the inner race, and next one should be the ball 6 and the inner race. So here it is ball 6 inner. Say OK, and this should be ball 6 and inner race. Okay, so all these contacts have been set up right now. Okay, so now let's go ahead and create the contacts between these balls and the outer race. So same way, call this ball 1 and outer race. Ball 1 outer, click on OK. So here this time the body I will be ball 1, but body J is going to be the outer race. Okay, so similarly do for the rest of the balls. So ball 2 outer race, next is ball 3 outer race, and another contact which is ball 4 outer race, say OK. So ball 4 and outer race, similarly ball 5 outer, and then ball 6 outer race, okay. So now you set up the contacts between these balls and the inner and the outer rims. So for each contact you're creating, you can see that the outputs are also getting created automatically. Okay, you have 6 more contacts to go. You need to also create a contact between the ball and the rim. Okay, so go here, call this ball 1 rim. Okay, so the body I will be ball 1 and body J will be rim. Okay, second one ball 2 and the rim. So even the last time I forgot to change the variable name, but now I cannot go forward and I cannot change this name. Okay, because the variable name can only be changed at the time of the creation of a particular entity. So it is ball 2 rim, say OK, ball 2 and body J will be the rim. Right click on this, ball 3 rim, so the body I is ball 3 and body J is the rim. Next ball 4 and the rim, so here body I is ball 4 and body J will be the rim. Next it is ball 5 to the rim, here ball 5 rim, so ball 5 and body J will be the rim. And now we create the last contact, which is the ball 6 and the rim. Okay, we forgot to change the variable name here, that's fine. So for ball 6 and the rim, let's select ball 6, body J is the rim. So now all these contacts have been set up. So there are 18 contacts in this particular model. Okay. So now what we'll try to do is we'll go just in order to save time further, instead of changing the properties of each of these contacts, we can directly go to the contacts property editor, which I spoke about it when I concluded the theory session. So if you just go here and you can select whatever contacts you want and you can assign the properties at one shot. So this is something I spoke about in the theory class. So we'll make use of that in this demo session. Okay. So click on all these contacts that you've created right now. Okay. So the way how you have to select all this is select the first one, hold your hold your left mouse button and drag till the end. This is the way you select all the contacts. Okay. So you turn off this particular box which says edit friction force. So you turn this off. Okay. Also turn off the edit event control. Okay. Under the normal force. Okay. So after doing this, under you can also turn this off under normal force. You can turn this off. So you can just keep this one active. Under the friction force, you can just keep this active. Set this to dynamic only, wherein you can apply the dynamic friction. Okay. So once that's done, you can apply the default values. You can leave all these values as it is and then say OK. So now the dynamic friction value is applied to all the contacts. To just check that, you can verify by going to say this particular contact. If you go to properties, if you go to friction tab, you can see that it was disabled earlier. Now the dynamic only radio button is selected and these are the default values that are assigned. Okay. You can just go to some random contacts and verify that this has been done in all the contacts. So it's there right now. Now let's try to specify motion to the inner race. Okay, and then run the model. Okay, so let's give motion to the inner race. So let's minimize all these in the model browser. So right click on the motion icon. So right click on this motion icon and you can give a label name as inner race motion. Okay, so here you can specify something called as inner race and then say OK. So here you are defining the motion by using markers. So say by using markers and select the rotation about x-axis of marker 2 in this particular drop down box. Okay, rotation about x-axis of the marker 2. So once this is done, for marker 1, double click on this, go to the body's drop down menu and then you go to the inner race and select the marker CM. Okay, and then select OK. And for marker 2, you go to the bodies and then you go to the outer race and select markers, center of marker. Okay, center of mass marker. So you selected those two. After you've given the connectivity options, go to properties. So you'll be giving this motion as an expression. So let's go to the expression builder. So it will be 360 times time. So 60. So say evaluated and OK. So we gave the expression now. Now let's go to the run option. So in the run option, you can go to the simulation settings. Okay, and then go to the transient tab. And in transient tab, you can change the maximum step size to 0.001. Okay, so this will help us in avoiding any convergence failures because we've set up so many contacts in this model. And then you close this dialog box. Okay, provide a name for this XML, say ball bearing contact completed, and say save. Okay, and now click on run and see if you're going to get any error message in this message log. Okay, so you can see that because it involves a large number of contacts, it's taking some time for solving it. So let's wait till the solver completes the simulation and gives us results. Okay, so its simulation is completed and now it's writing the H3D model and the result files. Okay, that's done. Now I can just say close and close. And for reviewing the results of contact simulation, we don't really go to animate or plot because a report is automatically created when you do the 3D contacts. Okay, to invoke that, you can go to view. To invoke the reports, you can go to the analysis option on the toolbar and then click on view reports. So here it basically shows all the reports it has been generated previously. So here you'll have to select the latest one that was generated. So and then click on OK. So then it will load multiple pages of hyperview and also hypergraph, and it will show you the results. Okay, so if you navigate through the pages, you should be able to see the report. Okay, so if you're not seeing this particular animation on the screen or a figure on the screen, then just go to the different pages and press fit. Okay, so there are 5 pages that are generated. So and this is the contact force plot. It has force on the y-axis and the time domain on the x-axis. So it's time versus the contact force. Okay, for the various contacts that you've created. So this is the 5th page in your report. Okay, so the first page is nothing but your MotionView page itself. Okay, let's go to the next page. So here you have the animation of the contact force. So just click on play. So wait till this completes and you can see simulation of a ball bearing. And to notice how the forces are acting, you can go to this particular option which says vector. Okay, so you can pause this for a second. So you can put the contact force total and you can select X, Y and Z components and go to display option. So here scaling you can choose around, you can put around 1. Okay, and click on apply. So try increasing this to 10. That's a bit too much. 5. So you can see the way in which these contact forces are acting. Okay, so let me play now. So you can see that, right? So this is how the contact forces are acting in the various directions. Okay, so this is the total contact force that I've chosen. You can also choose just the normal or the tangential contact force, or you can choose the contact penetration depth, velocity, or also the slip velocity. So you have all these options in the drop down menu. Okay, and in the next page you can get the contact overview. So you can get to know from this contour plot where you have the maximum contact force. So the highest value that you can see here is from this, it's okay, there is some red region. Okay, if you go and look at this location, it's red in that location. Okay, so that's where the highest contact force is there. So this is the contour plot that you can see. Okay, so once you get to know where you have the highest contact force, you can go ahead and try optimizing that particular area to get the best results. Okay, so this is how it is useful. So this is the contour plot, and in the next page it gives the animation of the penetration depth. Okay, so it says the maximum penetration depth is around 0.614. So this basically gives the animation of the penetration depth. And if you go to the next page, it is the plot of the contact force versus the time. Okay, so here you have all these curves. So, and that's why it's like, kind of looking very messy. So here, if you point out, you can get to know that the contact force of the fourth ball to the outer race is the maximum, right, from this plot. So you can try to isolate only that. Okay, so the ball 4 to outer, right? So it should be this one. So I'll try to switch off all others and keep only that one open. So control, I'm holding control key and selecting all this, and then right click and just say turn off. Okay, so this is how the contact force is there between the fourth ball and the outer race, and that's like reaching the maximum value very close to like 0.1 second or something, or even lesser than that. So this is how we analyze the report that gets generated after doing the 3D contacts. Okay, so let's go back to the first page, which is the motion view. So this completes your demo in contact modeling. Thank you.